What's up, ladies and gentlemen? I'm David Myers, teacher of mathematics at UTC South Durham. We are in a strange time right now, and most of you are sat at home thinking, well, this is all well and good, but what about my math? Perhaps you're in year 11, and you know fine well that you want to do A-level mathematics next year, or a course that relates a lot of the GCSE mathematics, and you need to get that course finished off. Maybe you're a parent sitting at home thinking, I need to make sure that they're focusing on their mathematics, but I haven't looked at GCSE maths in years. I can barely remember indices, let alone trigonometry. If the answer to any of those was yes, or that describes you, then this channel is for you. I'm a maths teacher and I want to share my lessons and my explanations of GCSE mathematics with as many people as possible to make sure that we're all keeping up with the GCSE mathematics content. Before we get started, however, I want to show you the website where you can get a copy of the resources that I'll be using in these slides for yourself. They're all free, they are all A-star quality, and they will be absolutely perfect for you at home if you want a slightly more interactive series of lessons. The website we'll be using for these videos is drfrostmaths.com because it is jam-packed with free resources for absolutely anyone. Whether you're studying GCSE mathematics, maybe you're in Key Stage 2 or 3, even at A-level mathematics and those wishing to study mathematics at university, there are resources for you available on this website. If you're just wishing to practice a single skill, you can type in the name of that skill, say for instance Pythagoras theorem. There's a set of questions that you can try and get instant feedback on, as well as other videos from Dr. Frost himself. In the meantime, what I'm going to be doing is putting the slides on screen with my explanation over the top, in the same way that I would deliver a lesson to every single one of my students. What you can do at home is go through these videos at your own pace. Rewind as and when you need if you didn't quite catch an explanation. We'll go through some trial questions to help you see if you've got it, with an explanation for some of the slightly harder questions that appear. They will then be left on the screen, the main questions, so that you can go through them. Half of the questions will usually be revealed after a few seconds, and all of the questions' answers will be revealed after that, so that you can learn interactively as best as you can at home. The links for all the slides that I use will be left in the descriptions, as well as any other websites that I happen to use as part of the resources. In the meantime, let's do some maths.
Today we are going to focus on forming expressions. Now, if you watched my video on simplifying expressions, then you'll remember I pointed out there were two parts to forming and simplifying expressions and using them in mathematics. The first is taking some weird and wonderful phrase, some random puzzle that the real world may or may not chuck at us, or the examiners, take your pick. And there are two stages. Usually we have to turn those words into some mathematics that we can use. It's only after we've done that successfully that we can solve the problems. So what do we need to think about? How can we take these random bits of language that are chucked at us and turn them into the mathematics that we can use? Now, if A represents your age, you might be watching this at home roughly around 14 or 15. You might be 30, I don't know. How do you know what your age is in 5 years' time? Say, for instance, I know that at the minute I'm 27, and in 5 years' time, I know I'm going to be 32. How did we do that? Most of you at home are thinking, well, that's obvious. I added 5. We can do exactly the same here. If we know right now that A represents our age or somebody else's age, we can simply say that A plus 5 represents our age in 5 years' time. Now things get a bit more interesting. What is twice what our age was 5 years ago? Let's just take that back a step. We know that 5 years ago, our age would be A minus 5. Well, why don't we just twice that? 2 lots of A minus 5. And use the brackets, by the way. Make sure that that's succinct. You can say 2A minus 10 if you want to expand the brackets, if you already know how to do that, but 2A minus 5 is perfectly fine. 5 years younger than twice your age. Again, think about the wording of that. Think how that's very slightly different to what we saw above. 5 years younger than twice your age. Twice your age is 2A, and 5 years younger than that is 2A minus 5. Half of what your age was 3 years ago. We've sort of done that already, just something slightly different. Our age 3 years ago was A minus 3, and half of that would be a half of A minus 3, or A minus 3 on 2. Me personally, I prefer to write these things in a fractional form. It makes things a lot easier down the line, especially if there's harder algebra to be done. But if you write half brackets A minus 3 close brackets, you are absolutely fine. Both of those are the correct answer. So we now have to deal with anyone called Bob, who is 4 times our age, and someone called Charlie, who's 2 years younger than us. Well, let's think about the age of one person called Bob. Thankfully, we can figure out that if Bob's 4 times our age, we're looking at a 4a. The total age of a Bob and a Charles. Well, if Bob's a 4a, Charles is 2 years younger than us, that's a minus 2. What we're looking at is 4a plus a minus 2. That therefore would be a 5a minus 2. The total age of you, yourself, a Bob, and 2 Charles. 2 Charles we need to think about very, very carefully. We know that we are a, Bob is 4a, and 2 Charles is going to be 2 lots of a minus 2. If you come back to simplifying expressions, again, that was done in video 1. If you need a bit of practice on expanding brackets, that may be helpful. But intuitively, we could know that 2 lots of a minus 2 would be 2a minus 4. We've just doubled everything up, which means that we're looking at a plus 4a plus 2a, which is 7a, and then the minus 4. We will come to expanding brackets later, so please don't worry about that. It's about 2 more videos down the line from here. Slightly harder one. Let's always try and keep it interesting. This is verging on what's known as mathematical proof. Proof is one of the most powerful elements of mathematics, so if you get this, you are well on track to understanding the core elemental philosophy of mathematics. But more on that later. The sum of 5 consecutive whole numbers is 285. First off, consecutive means one right after the other. So 2, 3 and 4 are consecutive numbers. 17, 18 and 19 are 3 consecutive numbers. 8, 10 and 12 are consecutive even numbers. They are next to each other. So let's just pull back to this. The sum of the 5 consecutive whole numbers is 285. The smallest of these numbers is what? Well, we don't know. We could be sat there for ages. We could be doing 1 plus 2 plus 3 plus 4 plus 5. That's going to get nowhere near. 100 plus 101 plus 102 and so on? No, so it's somewhere within that. So let's just try all 100 combinations and see what happens. I don't think. Let's try and be a little bit smarter about it. If we let one number be n, let's let the smallest number be n. The number that comes after that is n plus 1, then n plus 2, then n plus 3, and n plus 4. And it said the sum of those is 285. Well, sum just means adding them up. I can see if we count along, we've got 5 n's there. 1 plus 2 plus 3 plus 4. You can do that in your head, you'll come up to the answer 10, which means that 5n plus 10 is 285. 5n plus 10 is 285. 5n would have to be 275. And if you can do your 5 times table as quick as I can, then 275 divided by 5 will in fact give you 55. But you can figure that out for yourself later on. At least I hope I've got that right, otherwise I look like a massive idiot on YouTube right now. Or we could let n be the middle number. Because then we've got n minus 1 and n plus 1, n minus 2 and n plus 2. Actually, I'm really panicking about that right now. 275 divided by 5. Good, I did get that right, 55. Did I say 55? If I didn't, I was wrong, but now I'm correct, so it doesn't really matter. The sum of these numbers, however, if we started with n being the middle number, then we can say that the number before it is n minus 1 and the number after it is n minus 2. Adding all those up, you would get a value of 5n. But that means that 5n on its own would equal 285. To get your answer, take away 2 to find out that the lowest number is again 55. Up to you which way you do it. It doesn't matter how you model it, but the modelling it is the interesting bit. What I'm going to say is check your understanding here. I will walk you through these examples very, very quickly before giving you the main exercise to have a look at. As always, a timer will be here to show you when the answers are going to be spoken about. And we are back. I am just going to make my face ever so slightly larger so we can all see the main detail. Not that it really matters. We have cats costing £C and a dog costing £2 less. The cost in pounds of 4 cats, that would have to be 4C. The cost of 3 dogs, well, if a cat costs C pounds, then a dog is C minus 2. So 3 lots of C minus 2, if you wanted to expand those brackets, would be 3C minus 6. if there's a queue of n people, and there are q people in front of me, how many people are behind me? Now you can play with that mathematics if you want. You could say that there's 10 people with 3 people in front of me. It's very tempting to say that there's 7 people behind you. But you're one of the people in that queue. So actually, if there's 10 people in the queue, 3 people in front of you, then that's 4 people up to and including you, meaning there's only 6 behind you. Which means what we need to do is take away q minus 1. n minus q minus 1. If you got n minus q, don't worry about it. You're getting the idea, but it's just a little trick with the wording to be wary of. The average mark of people in a class was 60, so n is the number of people in the class. Now remember, if the total mark, as in the marks from everybody, is divided by the number of people, then we get the average mark, which basically means that some number was divided by n to get 60. So to find out the total number in the class, we have to multiply to get 60n. The total mark was 60 times by the number of people. If a new person joins the class and gets a mark of 80, the total mark now would be what the mark was originally, plus 80. This person's mark made the average rise to 62. So let's give another expression for the total mark of all the people. Well, 62, the new average, multiplied by n plus 1. The sharp attacks amongst you will be able to figure out exactly how many people are now in the room. But that's for another time. Finally, slightly more interesting one. This one I'm going to leave alone for a little while. 3x3 grid contains 9 numbers, 1 in each cell. Each number's doubled to obtain one on its right, tripled to obtain the number below it. Use suitable expressions to represent the 9 numbers. What expression gives the sum of your numbers? I'm going to reveal the answers, 91x, 6 over 7, and show you how we got that. But what's really interesting there is seeing for yourself if you can figure out where it came from. If you can, if you think you're feeling confident, then please leave a comment below. I'll be more than happy to comment and tell you if your reasoning's correct. For now, what we're going to do is shift on to the actual questions. As always, I'm going to hide for a little bit. I will reveal the even answers. No, I'm thinking the odd answers today. I'm going to reveal the odd answers today after a certain amount of time, and then I'll reveal all of the answers double the time after that. Can you make a formula out of that? And there you go. Forming and solving equations. Just forming equations. We haven't solved them yet. Sorry. However, forming equations, one of the trickier elements. You'll find if you know how to solve equations, this stuff is usually a lot harder. So if you can solve equations and you can now form equations, you are well on the way to becoming an incredibly powerful mathematician. As always, folks, if you have tried your hardest, that is the most important bit. If you know just a bit more than you did before, get some rest. Come and have another look at this video. See if you understand it after a good bit of shut-eye or some rest and relaxation. You've definitely earned it. Go and have a break. Well done.
That's it for today, folks. I really hope it's helped you out at home. If it has, please click on the subscribe button. Don't worry about the likes. I'm really not fussed about those. I'm not after YouTube glory or anything like that. I just want to know that you are feeling more confident in maths at home. If there are any topics that you really want me to go through, please just put it in the comments as well. The resources are also in the description below. You can click onto those and follow them through. There's Dr. Frost Maths. There's a link for the UTC South Durham where I work. If there's anything else that you need information on, please get in touch. Otherwise, take care.